Before starting, you should have Eagle installed. Any version should be fine with what we'll be doing. Ensure that you have the correct library denoted in the video that corresponds to the AP or micromouse capstone. Make sure that you have the green bubble checked here on the main page before starting. Now let's make a new schematic. Here is where we can assemble the parts and link them together so you can create your PCB. Place all components onto the schematic with the Add and Move commands. Right-click to rotate a part, and middle-click to move around the schematic. For the capacitors and resistors, if you're doing micromouse, make sure you are using the 1206 size. Please note the size, or your components will not fit when we order them. Once we have all our components on the board, we need to start connecting them just like a regular circuit. To do so, we use the net command, which is akin to a wire on the breadboard. We'll connect them in this fashion. This capacitor that is added to the circuit is known as a decoupling capacitor, and it acts like a backup battery to our IR receiver to ensure that it is provided with a constant source of current. Note that these will have special placement later on the PCB. Let's name these connections. Naming your nets will be extremely helpful in connecting them later. Now use the label command to ensure that it's easier to read your schematic. Labels are not necessary to create your schematic, but it will make it much easier to check and review with other people if you label properly. I'll route the rest of the circuit in the video. These routings should be similar to the distance sensor, Project 4, with an added capacitor. Please ensure that the connections are right, and you can even copy the exact way I wire them in the video. Please also name them and ensure they are connected. You can ensure that these are connected when renaming, and it prompts you with, would you like to connect this net with another named net? Once the netting is done, let's hit the ERC command. This is our electrical rule check to make sure nothing is messed up with the circuit. It says we haven't made our values for resistors or capacitors, so let's do that. Set the values on your capacitors and resistors matching those in the video. These will be helpful so that you won't accidentally put the wrong type of capacitor or resistor where it should be. Let's move on to actually placing things on the board. Click this button at the top left of your screen. Eagle starts us off working with a very large board, denoted by the yellowish-orange lines, known as the dimension box. Since we can't pay for such large boards, we need to shrink it down. Shrink it down to 1 by 1 inch. The default setting for Eagle is in mils, which is 1/1000th of an inch. Now type in move to move the components onto the board. You can rotate things by pressing the right click while moving things. This is the most important part. Make sure that the capacitor is near the 3 by 1 pin head. You'll want the IR LEDs next to the receiver and make them centered or off the side if you desire it so. So these white markings that describe some components are getting in the way right now. Hit the smash command, and this will allow you to move those labels away so you can start to work on the board. Alright, so things are on the PCB now, but nothing is yet routed. You need to make the electrical copper connections between the pins, denoted by the yellow wires, known as air wires. However, since we're making a PCB, and we have planes of copper, let's make stuff easy by using those planes. We'll be making polygons of copper by using the polygon command. Make sure you create your polygons on the dimension top and dimension bottom, as shown in the video. You can see these by the red and blue squares in the video, and you must name them matching the pin names you want your air wires to be connected, or it won't auto-connect these air wires you want it to connect. You want to name these that match the most common net on your board, which would usually be power and ground. Arbitrarily, we use top plane as 5 volts and bottom plane as ground. Type in rat's nest, and we see that some of the yellow lines disappear. This is because the copper plane did some of our job and connected those pins for us. You can get into fancy polygons, but we'll just stick with these two for now. Type in rats, @ semicolon, and the fillings will be gone. So now you can focus on the rest of the yellow lines. So now you have to fill in the rest of these air wires. Type in route, and you'll have access to the top and bottom planes to route. You can flip between the planes by clicking the middle mouse button, but I doubt you'll need to do so with such little amount of traces. Ensure the trace size is a bit larger than the standard specified. It must be at least larger than 20 mils in width. You can set the size of the trace in the upper boxes at the top of the screen. Now let's route the rest of the board. A good way to check that you haven't made any mistakes on the board is to run the DRC command. This stands for the design rule check. Make sure you load the oshpark.dru we have attached. Then run it, and no errors should appear. Please let us know if you run into errors, but you seriously shouldn't be if you're literally copying what I'm doing. Let's add some final touches to the board. Labeling things is always good, so you don't have to look back at what you did probably weeks ago, since all the information you need now is on the board. Note that not all white things will be seen on the board unless they are placed in certain dimensions. Type in the command text, and it will bring up a box which you can type stuff in. Click OK, and then you can place said text on your board. Ensure that you are using dimensions T-place or B-place, dimensions 21 or 22. T-place is the top plane, and B-place is the bottom plane. You can change dimensions through the top left area. Litter the board with random text, and it'll be great. The final step to creating your PCB is to generate Gerber files, which is a fancy term so that the fabricator of PCBs can understand what you're doing. Thus, go to the top left menu, search for the CAM processor. Click on that, and use the oshpark_2layer.cam file that we have provided. After running the job, pick out only the .ger and .xln files, and zip them up. Now send us both your .schematic, .bird, and zip files of the Gerber files, and you're done with the PCB creation.